Alright, troubleshooting. Figure 4.1 recommended method of checking the isolation reactor. The test closely approximate actual locomotive operation conditions. The reactors may also be checked with a short term since the reactor basically transfers from warm as alternating current, and any one of the winding will reflect all the remaining windings unless they are open and short. And a handy AC source is found with the coil within the NRV relay provided with the engine is not running when the engine idling of the 100 to 150 watt 100 volt test light connected with the series with the example for the 1-2 reactor winding AC voltmeter can be used to check the induced voltage in remaining windings. If the voltage across 1 and 2 is 20 volts, then 7 and 8 should be 47 volts, 9 and 10 should be 118 volts, etc. The volts, these values are somewhat due to the load imposed by the meter, but absolute values are not necessary. Alright, this shows your field reactor cores, and once again you have your 3 windings, 2 and 3 different windings. Milliampere meter of 50 volt cycle, 60 cycle AC voltmeters, auto transformer house current. Apply at 50 RM, 60 volts at the 1.5 volt. Repeat 3/4 full on the 2 milliampere reading. Some must exceed 750 milliamperes. The reactor should disconnect the battery field accelerator contactor and be kept on during the check. Notice that 3 and 4 winding is a common core with 1 and 2 winding. Therefore, all the windings are disconnected and no load is imposed. No voltage appears in the 3 to 4 winding. A short term was resulted in near zero voltage from 1 to 2. Hence, the other windings are similar with lack of the voltage. Resistance at the ground can be checked with a megger or the conventional manner. Opening windings can be checked with a good ohm meter. Alright, your field currents for 1, 2, and 3 motors, field motors, ohm meter, and 60 ampere fuse, your alternator, battery filler accelerator gate, reactor cutting out in the inside circuit of the field motor shunts, and on the far outside circuit loop you find the battery field. That goes to the top. Figure 2 shows the suggested method isolation field to be rectified. The engine need not to be rectified. Check the reactor load windings should be disconnected in order to prevent parallel resistant pass. The barrier field of accelerator opening, the operator should be flow the high resistant reading the negative lead positive side of the rectifier, low reading of the negative side. The low reading on the ammeter of the positive lead is on the negative red side of the rectifier, indicates a short or bad ordered rectifier. Here you have 2 different transformer governing current transistor, field S and F contacts 1 and 2, a transistor filling between the contacts X and L, X and 3 current, and AC voltage regulators put in between the GCT voltage of the ammeter and the transistor 3. The main generator goes on its on a loop with the ammeter at transistor 1, 2, terminal field coils 1, 2, and 3. Or 3 and governor transistor, voltage transistor, AC voltmeter, meter between the rectifiers of the rheostat and the transformer T4. Alright, when the engine is at idle, the feedback reactor is checked with the shorted turns for reading the AC voltage drop across the various windings shown in Figure 4.2. In the case of the voltage transducer, the governing voltage transducer, the current transducer, transductor, the governing current transducer, shorter run than one of the winding results, usually low voltage as well at the reactor. Figure 4.3 shows the recommended current leakage in the generated current transducer, the generated current transductor from the generated voltage transductor. As the isolation reactor's insulation varies the windings ground and check the measure of the windings that can be checked for openings in an ammeter. The teeth for transformer 3 and 4 are the conventional 1 to 4 ratio transformers, can be checked manner identically to those used in the reactors. For the governing generator current transducer, for the applied with 100 volts of the RMS 60 cycle, the coil terminals 1 and 2 current in the coils should not exceed 3/10 of an amp. The government test of the applied with 100 volts RMS cycle with the coils 2 and 3 and 4 with the current of the coils should not exceed 135 thousandths of an ampere. Apply 1,000 volts to the RM cycle with the coil 3 to 4 volts across the terminals 1 and 2 should be the maximum of 3/10 of the volt. Our figure 4 graphically illustrates the power load regulator relation. Operation main generator does not operate with above 1,000 volts. The operation lines are cut off at that point. The two lines are anchored with the 22,550 amperes, indicate with the higher load tolerance between the power load regulator should operate with locomotive travel at speeds between 18.5 and 12 miles an hour, or 16 to 15 gear ratio, bending approximately 700 volts at the 2,000 amperes occurs with the speed of 12 miles per hour. The line indicates the tolerance between the power load regulator will operate at a speed less than 12 miles an hour. The lines anchored by the 3,600 amperes indicated the total between the power load regulator operated with a speed between the 18.5 and 30 miles an hour. The speed approximately will vary for the motor temperature. The parallel motor connection above 30 miles an hour power load regulator used in aid of the snubbing of transisting overload, such as due to the motor field shunting of the wheel slip. The lower portion of the figure 4 with the vertical line on the 975 amperes will include the main generator amperes of the power load regulator, allowing during the dynamic braking. It should be remembered that during braking the power load regulator will operate the variable low amperages depending upon the signal from the brake control rheostat. Alright, this one shows the generator volts by with going across the generator amperes. The adjunctions of the rheostat are 4, 12, 5. A junction with rheostat 11, and a junction with rheostat 6 and 7. The bottom one shows the generator watt volts and generator amps braking. Generator amps times 0.4 or 400 for the general volt. The approximate adjusting the rheostat 5, 3 to 925 volts, 925 amps, 70 volt value at 70 volts of the 24T wire. And there's 11 volts approximately at the 74 volts of the 24T wire, which goes into your braking control system. Alright, every conceivable precaution failure has been taken in the design components of the circuitry. The GP13 transition relay, front transition relay, and back transition relay, power transition relay had provided with a reliable year of the service. The program switch has also been thoroughly viewed, tested, maximum reliable. The various switches used and accomplished parallel English contact. The circuitry directly involved with the program switching operation includes numerous safeguards aid against faulty operation. Illustrate the general procedure used with the troubleshooting. Check of the transition circuit, the installation of switch engine running of the relay contact shown. A step shown in the step down setting of the field with the transition program switch loading is showing the circuit of the main generator. The arrangement used for the checking operation transition relay, front transition relay, back transition relay. The loading shunt is removed with the current with the detected with the number 2 motor field. In order for checking the power transistor relay. This is the troubleshooting grid. This one's identical to the installation motors. This one shows is different. I can't just skip it. I just feel like skipping it. Should the transition occur with the suggestion off with the following articles may help the following cause the trouble. The transition cycle failure of the circuit of the back transition relay with the NMP coil with all the interrupting relay picked up with the T transition power switch 9 AB contact closed with the 300 milliamperes should be followed with an NMP coil at 74 volts. The back transition should pick up. Fill the front transition relay P and N coil circuit with the P2 and P4 and TR and F field shunt 3 and field shunt 4 contacts closed. Approximately 94 milliamperes should flow from the front transition relay to PN coil through the 74 volts with the P side at the coil positive. 3. The lack of motor field shunt perform a power program switch sequence check that may be done with using the MG with the set connected with the testing jack set up with the program switch, the isolation switch to the run position, engine run switch to the off position, the MG set with the voltage should then be to reduce. The program switch may be stepped up one step at a time per momentarily placing the engine switch on the on position. Lack of dropout of the delay of the interrupting relay. The relay should be drop out approximately 1 second after it has been de-energized. Loss of the time. It indicates bad order seat at the capacitation of 26 and rheostat or 40. Faulty calibration limited with the resistor circuits of the front transition, back transition relay operators brackets provided with the loading of the shunt fastened with the short circuit main generator operation of the front transition relay, back transition relay. Thus be checked with the various main generator for the main generator currents while the main MG sets apply the voltage of the operating coils. Faulty calibration limiting resistor circuit of the power transition relay operating coil lower current value through the power number 2 traction motor field is necessary to check the calibration of power transition relay resistors. The current may be obtained with the locomotive brake set with the preventing movement while the control setup for the dynamic braking locomotive is equipped and an MG will apply with the voltage operating coils. Failure to make the transition. If the unit load properly transition position number 1 program with the switch sequence check the MG, but it will check the circuit continuity without the limiting the resistor transition relay operating the field shunt transition relay power contactors can be checked during the sequence check. If the program which sequence checks properly contractor's operation satisfactory, they'll check the operation transition relay described in steps 5 and 6. Our figure 4 shows the general producers of the testing setting of the performance control system. The prohibits proper presentation complete diagram and inspection setting of the test, but the diagram should provide some idea of the proceeding for the test. Figure 4.7 shows the various adjustment required for the GP35 dynamic brake. Once the proper set with the adjustment should be not changed, but the troubles and counter circuit should be checked. But for the set and temperature should be changed. The adjustment, the dynamic braking relay operation checked for the connecting the MG set input across the main generator with the connecting of the MG the set output across the resistor coil, the Zero diode braking regulator circuit, the control setup with the dynamic braking power jump applied with the operating braking control lever that will excite the main generator. The dynamic braking relay will regulate the voltage corresponding with 700 volts of the dynamic braking current with the dynamic braking relay operating with the check several seconds should be allowed with the capacitor with the circuit between the full charge rheostat 10 with adjustment with the obtaining the regulation of 700 amperes of dynamic braking current. Braking wheel relay operation check for the connecting of the main generator set input the set across the battery adjustment with the resistor for the brake wheeling relay for the correct pick up and the dropout brake wheeling relay. Alright, this is your main generator set. Braking wheel relay. Motor field is obtained with adjusting the 10 ohms resistors and W wheel slip pickup at the 55 volts across the traction motor. Your wheel slip relay is right next to the series and gate and on the circuit between your 2 and 3 2 and 4 and with 1 and 3 traction motors fields. A brake control handle is moved toward the maximum brake position voltage drop the zero resistor of the RE increases the 0 to 25 volts of the 24T wire increases from 0 to 50 volts of the voltage drop across the zero resistor of the RE equals the holding voltage of the 25 volt zero diode. The zero resistor of the RE1 longer effect with the drop across the G2 remains the constant 25 volts with the drop across the R2 increase applied voltage. See figure 4.8. The current magnetic amplifier driver verifies the time of the relation of the time on in relation to the time off power load regulator. Relationship conjunction with the DK battery field with the rectifier battery with the result of the battery field current is essentially with the contact proportional potential 24B wire maximum brake handle position battery field current should be the 15 amperes of reaction base current with 135 to 160 milliamperes at 75 volts. The reactor derived with the current shall be approximately 65 milliamperes at 74 volts. The following are a few aids of troubleshooting and dynamic braking control. 4H of the dynamic braking zero characteristics voltage drop across the RE stat. Applied voltage from 25 to 50 to 75 and between the drops across 25 to 50. The voltage of the power load regulator current terminal. Also, the auxiliary generator powers are negative through the first current coil of the brake control rheostat 24T wire through the which also from rheostat the rheostat control goes through rheostat 1 through to the around the 25 volt zero diode and G1 G2 the pole and R2 and R1 are on the contact on the second loop, but also in between this wire split between the 24-2 wire to the power load regulator coil and the reference of the voltage. Lack of motor field current. Check the voltage at the 24T wire. Loss of the voltage indicates the trip control brake of the faulty brake control rheostat. Check the reactor 11 to 12 driver coil current. Failure to the BK contactor close of the circuit and check the circuit with the contact of the BFA and fuse the missing with the blown checking condition. The reactor rectifier suggested the text adjacent to figure 4.1, 4.2, and 4.3. Check the main generator voltage shown in figure 4.4. Excessive motor field current. Check the loss of the reactor base coil current. Check the shorted rectifier compensation coil circuit. Check the power load regulator operating setting. The rheostat 3 brake warning relay action. Check the loss of the reactor base coil current. Check the excessive reactor driver coil current. Check the dynamic braking relay operating previously described. Check the short rectifier compensation coil circuit, and the brake war relay action. Check step 5. Check the brake. Pick up the brake wheel relay with the main generator set at least 5 minutes if 1,000 1000 volts to heat the relay coil and resistor. Check against the value indicated with the locomotive wire diagram. From the collection of Tom Gardner from the R&R Fallen Flags .org website. And that completes the Locomotive Control Electric Motor Division GP 35 Static Control, March 1964, Service Department Electric Motor Division, General Motors Corporation, LaGrange, Illinois, USA.